Okay, I've gone live. I'm just checking if my mic is set correctly. Uh, I think people are excited to see Nischay after a while on the channel.
Hi guys.
I can hear you. Perfect. I can hear myself. I was going to take my headphones off. I'm just used to doing it myself now. But hey everyone, thanks for joining. The channel was feeling a bit lonely for a while, so I brought back Nischay since he's so good at explaining a lot of stuff. And I'm happy to again bring back Nischay. We'll be going through BirdClef. He'll be explaining his baseline for BirdClef 2023, and then we'll go through the 2022 and 21 solutions. So Nischay, thanks for coming back on the channel. I can see your baseline in the background for another competition, so I know you're working on other stuff. Is the,
Maybe I should switch my tab.
don't you feel
Yeah,
something else is
thanks for
missing?
having me. Yeah.
Don't you feel something else is missing?
But
I think something else is missing, no?
I don't think so.
I think so.
Okay.
Let's just put the logo in a good lighting. Okay, I'll
By
stop
the way,
trolling Nischay now.
how do we leave the meet?
Okay, I'll stop trolling Nischay now. But Nischay, thanks again for joining. We planned this was unplanned this time, as you can tell. So I was just figuring out how to do this. So I brought Nischay because he's really good at understanding the competition, and he's already shared a baseline. So I wanted to invite him. I also had basic questions like what is the difference between AP and MAP, and on his screen he apparently figured it out. Um, so this is how we figured it out, by the way, if you're curious. So this was our preparation. But thanks for joining. I can see Alex in the chat. Hey Alex. Hey Korean. So I'll literally end the jokes now. I might troll him as I would throughout the live stream. But we'll start by going through the competition. So I also wanted to point out a wave app that Grandmaster Beluja has created. So this was from 2021 competition, but you could install this app, and if you upload a bird's audio to it, it can identify to some accuracy. So this wasn't the best performing model, but this is basically giving you the gist of the competition. And Nischay, correct me if I'm wrong. You need to identify birds or these rare species of birds based on their recordings from forests.
Correct.
And I think the challenges also were that it was, since it was a like recording in the forest, you could have like background noises, and then also like there were different people recording it. So the devices used for recording it were also very different. Is that a correct overview or like a short summary?
Yeah, I think so. So the ultimate goal of this competition is to just identify those birds based on their audio. So
Thanks for that. So we'll start by, so we're doing something different. Instead of going directly to the top solutions, we're looking at an actively going on competition. And Nischay has already shared a baseline here that scores quite well. So he says it's LB 0.78, and I'm sure many people would have jumped above you now, right?
right, I think there's this one grandmaster of SAF. He recently shared a baseline with 0.80 score. So the leaderboard is kind of clustered for now.
Drums voice versus birds voice. Even
Yeah, I
on
was
public LB,
actually.
you're not on gold, Nischay.
Mhm.
I'll try to refrain from this, but I'll ask for your help to understand the baseline. So if you like, we can start here and start going through the baseline.
Sure, sure. So should I present my screen?
Sure, go for it.
Okay, just a sec.
Your friend Adi is in the chat, I think.
Mm, okay, I think it should be visual, right?
Yes, please
Hmm.
continue.
So there is another baseline which is recently shared by Afsaf. I would also like to mention it. Maybe we can go through it later also.
Sure.
Mhm. So yeah, maybe I could directly start off from my notebooks only.
Mhm.
Okay, I think all of my notebooks are visible now.
I'm just seeing the screen of the discussions page still.
Oh, oh,
I think you
Okay.
need to open in the same window. If you open a new window,
Right,
it doesn't
right,
appear.
right, right. Okay, my bad.
Yeah, so I didn't see your private code this time. We need to make him do some private sharing today, people. Let's try to distract him.
Yeah, so I think my solution is kind of in three stages. It is a multi-stage solution. So the first stage is basically I try to create a stratified split, the best split which we could basically for validate our data set. Along with that, I tried to create the MEL spectrograms as you could see. So for this, I basically first I try to load the dataset and try to figure out all those birds which have very few samples. So as you could see, these are our primary labels which we need to predict, and these are the name of birds. So as you could see, some of the birds have just one sample, so it's really hard to create a robust validation split. So what I did was I simply put all these birds into a training data set and did a stratified split train test split based on the other birds which were left and which have multiple samples. So this is my split. I did 80% to 20 percentage of training to validation data, and I simply created a data frame out of this and converted that into a spectrograms images basically. So for creating into spectrograms, there are different libraries which you could refer. The one which I used was Librosa,
Mhm.
and I just simply loaded the audio files and created the 5 second span spectrograms, because as you could see in the competitions page, they oh it again opened a new tab.
Yeah, that's a problem I always run into. So you
Yeah, so
want it
how
in a
should you
new
do it?
tab. Open in a new tab instead of new window.
Okay, I think I only shared my one tab. Maybe I should share it again.
Yeah, just reshare.
Okay.
So in the meantime, many people prefer torch audio. Why did you prefer mail spectrogram over torch audio?
The main reason was firstly, yeah, so the main reason for not using torch audio was it is mostly preferred while you are converting mail spectrograms during training itself, right?
Hmm.
So my goal was to just make use of the CPUs and simply convert all those audios into MEL spectrograms before
Hmm.
end training, so that the dataset loading part becomes faster, and I could run more experiments alongside. Because it's not a preferable thing now. Like you always convert the audio into MEL spectrograms and then you start the training alongside. So
Hmm.
that might save some compute, but there are few training techniques such as SCD models, or if you want to make use of complete audio files, then maybe it is a better idea to use torch audio library.
Okay, makes sense.
Yeah, so as you could see, we have training audios, and our dataset consists of training and testing data, out of which in training, if I am not wrong, there are 264 birds and each bird consists of some files. And the thing is, in audio dataset, the audios could vary in different seconds. Like it could be of just 30 second, or maybe it could reach out to 5 to 6 minutes audio as well. Whereas in test data, it's fixed that all
Okay.
the audio files are 10 minutes long. So that is a thing. And secondly, our sample summation, as you could see, should be in the format of 5 second span. So
Oh,
this is basically a row ID, and for each sample you have to predict every 5 seconds.
okay.
So what I did was I created a split in such a way that it extracts the spectrograms in a 5 second span. So I set all these parameters and created
Hmm.
the spectrograms and divided them into two folders, train and validation.
Hmm.
Now we can jump on to our stage two, which is basically training it. So yeah,
I saw your top submission title. You were using ArcFace and what else was there?
just ignore that. Maybe I should public that as well now. Anyways, so yeah, this is basically I defined a config file and I simply loaded the stage one dataset into this notebook, and Yeah, so I'm using PyTorch Lightning if as I don't like the TensorFlow much, so I preferred making a baseline in PyTorch. So this is our data loader. Currently, I'm just simply randomly sampling all those spectrograms based on 5 second durations. And for validation, if you could say, I'm just using the first spectrogram, which is basically 0 to 5th second of our audio file. So that is a thing. Like maybe you can extend it a bit for a better validation. Yeah, this is all data loaders. So this is how the spectrograms looks. If you could see them,
Mhm.
and yeah,
So
I
these
think
are
that's
black and white. So these are single channel spectrograms, right? So when you are
right.
feeding
These are
them,
monochannel. So
so do
you
you like copy them over into different channels when you're feeding them?
yeah, for that I simply did the stack of all those images. So it basically the same one channel image is stacked 3 times to make
Okay.
it a 3 channel image.
Are there any other approaches? Because I know this is like the most common one. Uh,
I think you could simply use single channel as well if you are using a TIM library. So
hmm.
it now also has an option to just simply use single channel images, and then it alongside convert it into 3 channel based on the first convolution layer. So you can use that as well, but it shouldn't make much difference, I would say, because at the end of the day the model is pre-trained on ImageNet dataset, right? So
Hmm.
it shouldn't create much difference if you are using single channel or 3 channels.
Makes sense.
Yeah, I think that's it. One another thing I can mention is the introduce of new evaluation metric, I would say, in this particular competition. So in earlier competitions the metric used was F1 score, but this time they introduced a new metric which is also known as padded cmap. So
Hmm.
they also shared the code. That is one good thing, like they shared the Python code itself, so we can just simply evaluate our models on their actual metric. So this is the function in which they are basically like using a map metric. So map is nothing but mean average precision. So one positive aspect of this metric is like you don't need to threshold your predictions now. So it makes it easier to just simply generate a submission file, and your solution might be more optimal based on this metric, because in F1 it is kind of very threshold tuning, which I can show later. Like in previous competitions the people used to do so much of post processing, like
Hmm.
tuning threshold multiple times, and
Hmm.
based on that they were doing post processing, which was kind of overfitting the metric. So to overcome that they introduced map function, which is a really good thing, I would say. And also they padded the they padded 5 more samples to each bird. So it is a way to simply tackle the imbalanced dataset thing as well. So this is a good thing, and I in this particular competition I kind of find the CV and LV correlating well.
There's also like the challenge that if you have a long enough, let's say you have like a 3 minute long clip, there could be a chance that there's like the bird noise or the bird sound is only heard once in that clip. That I'm not sure if it's true this year, but it was true last year, I think.
Yeah, that is always a case. That is why, like, even at the submission you have to predict for every 5 seconds.
Makes sense.
So it could be a possibility that in within one audio there could be multiple birds as well. So we just need to predict based on those 5 seconds. That is why I generate spectrograms in a 5 second span for training as well.
Makes sense. Thanks for that. I'll again post the link to Nischay's discussion where everyone can find this notebook. So if you all want to jump on this competition, I always appreciate Nischay's kernels because they're very well written in code. Sometimes he doesn't write many comments, but for that you can just
I
ask
never
him on
write
the
any
kernel
comments.
discussion. Just ask him in the kernel comments, and he usually gets back. No, thanks for that overview. So I think we'll also point everyone to Osif's kernel. We'll let you read that, but it might be worth into diving into the older competitions. So we our agenda today is to cover both 2022 and 21 top solutions, which I think is very ambitious, but we'll see where we can go with it. So that's the plan for now. Continuing in the older style, what I'll do is I'll try to explain the problem, and Nishya will keep helping us wherever I mess up, and together we'll try to understand these top solutions. So my aim is to like maybe understand top five from both the competitions. Again, I think the app I showed earlier probably gives you a good idea, but it's a competition of identifying bird sounds in these in the wild audio files. I tried earlier, but even if I play this sound, it might not come across to you guys. So what I would suggest is just go to any folder, just download these files and play them. They might open in your iTunes, which will sync throughout your Apple Cloud library, but that's okay because it should be a sort file, but that should give you an idea of what you're trying to work with. And there are one more thing. Last year, there was this rating criteria added. So these were random species, not random. These were rare species identified in the wild. And the audio recordings we are listening to were recorded by different folks or different people and uploaded to this website. So these were also given a rating, like how you'd rate a star or rate, let's say, chai time on a streaming platform. You would also give a rating to the quality. So these range from zero point 0.0 to 5.0. And again, a lot of these didn't have ratings, but it might have been a good filtering mechanism. So, for example, you could filter out the lower ones. Maybe I would say, I don't know, I would probably filter out recordings with a rating lower than 2, maybe. Anything else you want to highlight, Nischay, from here?
No, I don't think so. Yeah, there is also secondary levels if anyone is not aware. So it is basically showing that there could be a possibility of some birds present in the background. So for that, they also provided secondary levels, and maybe you can make use of it in the competition. Many people have utilized it in some way. So
Makes sense. Um, Okay, I have some notebooks open, but Nishchay's introduction today should cover it pretty much. The basis of all of these competition hasn't changed much, but it keeps getting harder as you can see. So last year we didn't have this 5 second window prediction rule. I think you had to just predict over the entire test sound images. But the basis remains the same. You take the audio file, you convert it into a spectrogram. On that, you figure out what models you want to load. Many people use the SED model that Nischay mentioned. People use different techniques. You could do pre-process them, you could post-process them differently. That's the overview of all the solutions, simply put. Would you agree with that?
yeah, mostly yeah.
So I think we can still go through just the top two solutions to respect the competition. So this is by Shreya Sajjal, and this teaches you how to first of all extract the features using Librosa. Nishchhay just walked us through this, but I'll quickly show the older competition as well. So you can see some of the common names of the species are Acadian flycatcher, and you can see the author, you can see the date of recording. So you also have the latitude and longitude. Earlier I showed the app. These are, I think, mostly native to different areas in America. So you have these longitude and latitude values along with the rating that we had looked at. I don't see the secondary label here. It's here. Sorry. So we can see that there's a secondary label for some of them. Some of them are empty. So these probably have another bird in the background. Looks like. And then you also have the type of the sound. So it could be a bird call, and these are the other options. So it looks like begging is one of them, juvenile is one of them. And this basically plays through a few files. Then you learn about different visualization techniques you can apply to it. How do you create the spectrogram? How do you take a look at it? So this notebook would give you an overview of how to use that with Librosa. And this is by Shreya again. So thanks, Shreya, for creating this notebook. Any other tricks you want to highlight, Nishчay, from your current top solution?
I don't think so.
Okay. I'll keep trying. I'll keep trying. Um, Here's an EDA notebook by Hassan, I believe. So one thing I wanted to point out, Nishchay showed in today in the recent competition, there's a class imbalance. You can see it's quite prominent in the last year one as well. So that's not an added challenge, as I understand. This has been going on for the past years. Which means if you are watching this video and going through these older solutions, it might be relevant to the current one as well. And here's the visualization of the rating. So it looks like the lower rating one by themselves are quite low in number. So I would probably like remove maybe zero point 0.5 to 2.5 ones. Nischay, would you like remove them? Would you keep them?
I never made use of this particular feature, so I have no idea.
But is that a good strategy? Would you say to like remove the low rating ones?
I don't know if the target particular depends upon this rating
Hmm.
feature. If it does, then maybe I will think over it. So
Hmm. Makes sense. Let's see if there's anything else worth highlighting. So you can see here's a label, secondary label length. Um, so it looks like it's mostly zero. A large number is zero. So most of the times you don't have a second bird in the background. In some cases, you have three birds in the background, so it can get complicated really fast. But that's one of the like very few cases. It looks like less than 100 if I'm eyeballing it correctly. I think that's all I wanted to highlight from this notebook. So I was wrong earlier. I said most of these birds are from the US. I think that was for the 21 competition or the one before that. So there have been three competitions, I think. And what I mentioned was like true to one of them. So you can see that the birds are this time from all across the globe, even from like places I don't know what these islands are, but it looks like we have birds from there as well. And there was this another thing worth highlighting. You could have applied noise reduction. So if you listen to the audio files, which unfortunately I can't play in this, they have like a lot of wind noise in the background as well, and you can like hear water flowing in the forest probably. So you need to figure out how to apply different techniques for pre-processing to that as well before probably creating the spectrogram. And that's another thing you can optimize for in your pipeline. So that's this was the EDA and quick overview of the 22 competition. Anything that caught your interest, Nischay, that I might have missed?
no, no.
Okay. The Kaggle master approves, so we'll continue. Nishchay's pain point, if you all haven't been following along the joke, he's been sincerely pushing for the last solo gold medal, and unfortunately, he's missed it a few times. And every single time, as a content creator, I've made the proper use of the opportunity to troll him live. So that's the running joke, and I'm saying it to his face just to troll him.
As Ayushman mentioned about coffee, here is my coffee, Ayushman.
I think we can't hear Nischay, right? I think he's dropping from the stream. He might get kicked from the stream somehow. I feel like. Okay, let's continue. I think throughout the competition, people share these different experiments. I had these open because I wanted to go through them, but then I realized the top solutions can just also be self-explanatory. So I'll jump to them and keep highlighting a few things. So CPMP in this one mentions the differences between 2022 and 21 competition. So Nishcha, maybe I'll ask for your help to go through this since you've been quiet.
Hmm. Yeah, so firstly, he is highlighting about the metric part itself. So in 2021, the metric was F1 score, which was being calculated sample wise, and then it got converted into macro F1 next year, which was based on the multi classes classification. So we were calculating column wise and like giving weights to the birds which has lower samples. While this year it completely transisted into map metric, which is basically mean average precision. So as I mentioned earlier, it doesn't require any thresholding, so that is a big plus for me. So that's the first point he's trying to cover up. Also, he's mentioning about that in last year there were some soundscapes which were annotated every 5 seconds. So yeah, I just remembered. So in 2021, the host provided a validation data set as well. And in that validation data, there were some labels which were for every 5 seconds. So our ultimate goal is to predict for 5 second span as well, right? So that way, there was some correlation between those validation data score and the leaderboard score. So that was a good thing. This year they didn't give it, but somehow maybe we can just simply
Throw a
convert our
little.
training and validation data into 5 second spans as I did, and then calculate all across the audios. But there might be some noise present in that way, so
Hmm.
that you may have to deal with that. So
You could also use pseudo labeling there. I feel like with different ways to balance out. That's just me. I haven't even joined the competition. I think I'm just thinking from the sidelines here.
Yeah, I think we can make use of pseudo labels somehow. Like, it can come up from the idea as Afshaf has shared about the pre-training part. So what he might have actually done was, I haven't tried his solution yet, but what he might have done is, like, he used earlier competitions dataset, training dataset, and he just simply pre-trained a efficient net model, just like on ImageNet you pre-train a model. He fine-tuned the model on the previous year dataset and then used those weights as a transfer learning for this competition. So that is how he got almost 2% of boost.
Hmm.
So similarly, we can also make use of pseudo labels as well. Like, we can maybe extract out all those audio files which have same bird present, and then just on those birds we simply try to train our model and generate the pseudo labels, and then use those pseudo labels along with the training data of this particular competition. So that could be a possibility. I'm not sure how well it will do.
Okay, thanks for sharing that. I was trying to extract if you are using that or not. Looks like we're not clear about that. Um, looks like by the end of the stream, Nischay will probably fly down to my home and start beating me. It looks like. um, yeah, we can see from his smile it looks like that.
Where is
Okay,
my coffee?
sorry.
No, I was just looking out for my coffee. Anyways, you can
I didn't hear
continue.
that. Sorry, what? Okay. So those are the changes I think. Yeah. So this is what I was getting confused with. Last year, all recordings were from Hawaii, and I think in 21 it was just from Hawaii, if I understand correctly. I'm getting confused between the map visualization and where the birds are from. So I'm not sure if it represents where the bird species originated from or where the recording is from in the notebook we just saw.
I think it should be the same thing. The map which you showed about the world map, that might have been plotted from the latitude and longitudes given for each sample. So, but that was for 2022 data, right? This is Hawaii one is for 2021, if
Okay,
I'm not.
right. Okay, so in 21 it was just from Hawaii.
Mhm.
Okay,
And
that
I
makes sense.
think this year most of the audios are from African region, if I'm not wrong. So
I see. Okay. That's pretty cool that the organizers are going to different regions everywhere. It looks like they're targeting different rare species and trying to help them. So that's pretty awesome to see. Wanted to also highlight that this competition was around the time when transformer models for audio were just starting to come around. In the sense that it was worth enough to start a discussion where people, as you can see, probably discovered through this one that hey, there are actually transformer models for audio now, which now is like more common, but at that time they were just starting to come out. So we'll probably go to the first place solution now. Let's do this, Nischay. I'll cover the first, and you can probably try to cover the second, and we can alternate to keep it
sure.
interesting.
Mhm.
So there was some controversy in this one with a model being available that ended up performing really well. I won't get into that. You can read about it, but there was some discussion around that. For the top solution, they say they did use the available BirdNet along with other models that they had created. And in this post, they share their approach. So they had used the SED architecture, which is a bit of a rabbit hole. So you go to Tawara's discussion from 21. And here, if you read through, he takes you to another kernel where the architecture is defined. So this is called Tim SD. He's called the class that, and basically, if you read through it, you can understand that he's creating a spectrogram at first. From there, he's creating a log mel spectrogram feature extractor. So he's extracting the features by creating, as I understand, a log plot from the spectrogram. Is that correct, Nishya?
Yeah, so basically to generate a spectrogram, we first do a Fourier transform. Basically, we find the DCT of the actual raw signal, and then on that particular signal, we basically want to have an image which consists of frequency versus time domain. So for that we generate a mel spec, and then we apply log function overall. So
Okay.
that basically generates our log mel spectrogram.
And I think that I'm like trying to make logic of it, but that makes sense because audio recordings can be so high, and log would probably normalize that to a normal like graph,
Right, high
I'm
and low
assuming.
thing is for amplitude, right? But
Hmm.
if we do a discrete cosine transform, which is also known as DCT, then it converts that into a mapping of frequency versus time. So for that, it doesn't matter like how your what your amplitude was, because it
I see.
has been e- eliminated right from
So
that
what's the
particular.
logic for applying the log transformation then?
I think there are few things, like firstly, if we take a raw signal, then you can't just simply train a 2D CNN model because those are in 1D arrays. So for that we basically try to extract mel spec. So like firstly, after applying DCT, there is a possibility that there could be some noise reductions from the raw signal, that as you mentioned there could be lots of ups and downs in the amplitude part. So for that could somehow get normalized. And also, like before converting to mel spectrograms, we use several band pass filters. We use band pass filters. So what basically band pass filters does is it takes a minimum frequency and a maximum frequency, and it chops down the signal between those frequencies. So
So it's like
that's how,
gradient clipping for audio.
yeah, somehow you can say it. But for signals,
Okay.
you just simply apply band pass filter. Also, it somehow shows you a better spectral diagram of that particular audio file. So that is why we make use of mel spectrograms. So it what it basically in simpler terms does is convert a raw signal into an image, and then we could simply use that image. Using a convolutional network, we can extract better features from it. So
That makes
at the
sense.
end of the day, the only thing matters is like to find a signal from us from the audio, right?
Hmm.
So like you could make use of raw signals as well, but for that you might have to apply 1D CNN or convolutional networks with only one dimensional kernels. So
Hmm.
that that is also a possibility, but that mostly works for smaller time spans. But in this case, there are second the audio is of several seconds and even minutes, so that
Okay.
might not work that well. So
Makes sense. Thanks for clarifying that. So we were understanding what is this SED architecture, and we went into the rabbit hole of understanding how do you create these feature extractors and the logic behind why you use a log transformation there. After that, you can probably apply some augmentation. So these are spec augmentations where you, uh, I think, drop some frequencies after a while. I'm again blanking out on this.
I haven't used this particular function, but there are certain spectrograms augmentations, like you could simply mask the time or frequency domain part. So it is similar to the
Dropout.
cut mix, and yeah, those all those augmentations which are present in images, but these are for spectrograms. So they also make somehow use of that time part as well. So
I see. So after that, you create a batch num layer through which you pass it through TIM backbone, and inside that, it's just a few sequential layers. Finally, I think we are using efficient like feature extractor here, where we pass in the in features, right?
mhm.
And finally, I think we apply an attention block to it, and we run this through a forward pass and simply train this. So that's the SED architecture. I try to draw it on paper, but there's no like simple, it's like quite straightforward. You just apply this, you extract the spectrogram, you apply a transformation to it, you apply some augmentations to it, and from there it's pretty much a simple neural network, simple so to speak. So this is the SED architecture.
One good thing about SCD I can mention is that it generates both the prediction for complete audio file as well as for the time span which we want, which is 5 seconds. So that is a good thing. Maybe you can make use of both the predictions and somehow do some sort of post processing based on that, because it if there is a audio present, then there is kind of a possibility, no, that if a bird is present from 0 to 5 seconds, then there is quite a possibility that it could be present in other time frames as well. So for that, if we are using SCD architecture, then it somehow make use of entire audio clip and generate features based on that. So maybe those clip wise and all, all across the prediction of audio can make, you can make better use.
Makes sense. So they share some more details about the backbones they had used. It looks like it was a EfficientNet B3 and NFNet L0. The first ride was changed from 2 comma 2 to 1 comma 1 in order to have larger in terms of length and frequencies output of CNN encoder. And this trick originates from ILU from SETI competition. And if you haven't watched, I interviewed ILU just just a few days ago, so you can learn more about his journey there. This was the first time I believe we didn't just see the graph; we got to see the person. So I'm quite fortunate. Both of us are quite fortunate to be colleagues with him. After this, they say they had trained the model on 15-second chunks with secondary labels, and they had used the following augmentation. One thing that stands out is pink noise. So if you are an audio connoisseur or one of those annoying people, you would find out that there is white noise, there is brown noise, there is pink noise. I think there's yellow noise as well, and these are defined based on the frequencies and some very fine nuances. And the problem is different connoisseurs mix up these names as well. So pink noise could also be brown noise in another community, and brown noise could be pink noise. So I'm not sure which one this is being referred to, but it's simply like noises or in certain frequencies. Some people use that to increase focus or when like before going into focus mode. So many people also listen to brown noises before doing focus mode. Nischay I heard listens to loud rock music while making some missions to Kaggle. So that's his brown noise, I think. Um, they say for background noise they had used a dataset which would be I think this tab, the one before it, from environmental sound classification 50. So I think they had added some background noises just by using this data set. They say they have used weights computed by primary label for data loader and loss in order to cope with the unbalanced data set, especially for scored birds column. For loss, they had used a simple BCE since it's a classification problem on the clip-wise logits. And finally, he was tracking three best checkpoints by both leaderboard and validation loss. And finally, he averaged the three model weights. It looks like he says it's a stochastic weighting it averaging, so it looks like he was just taking a simple average through the weights. For training, they say they had pre-trained on 2021 and 22 com data and then fine-tuned on data from pre-train but filtered by the next rule. The rule being take samples which contain scored bird in primary label or secondary label. For inference, he says there are two options to infer the ACD model. There's a and rule here. So for long and short clip-wise predictions, short being 5 seconds and long being 15 seconds, feed the model 15-second chunks, but apply the attention head only to the 5 seconds reduced CNN image. And then he shares the validation strategy where he had created a 5 CV stratified distribution and a few more details which I'll skip. Finally, he shares the score as well as the inference kernel, which you can see is absolute Kaggle level, fork of CLS, and the GitHub repo as well. So if you want to dive into the code, you can find both of these links in the write-up. Nishi, you want to highlight anything that I might have missed?
No, I think you have already covered. Yeah, one more thing I can mention is like in most of these 2021 and 22 competitions, most of the people use cross validation split, which was like generating 5 or 6 faults based on the data. But in this particular competition, there is also a constraint of using the computation. So while you submit your model, there is only 2 hours limit to for the inference part, and that too on a CPU, not on a GPU. So it has to be a quick and a shorter model. So I don't think you could fit in more than 2 or 3 models in this particular competition. So that is why I generated a split based on simple train test split, but stratified on the primary level.
Okay, that makes sense.
Yeah, so
Uh,
in this competition, I don't think so. There would be many ensembles, long, several models ensemble present in this competition. So
for the 22 one, right?
for 23 one,
Okay, cool. Do you want to cover the second place?
yeah, maybe you can start off. Hmm. I will publish. Yeah, so
Yeah, I was also trying to laugh at this, but it's quite funny.
yeah, so
They
I
like
think he has mentioned he made use of that particular model, which was somehow been leaked on GitHub, and with that, without that, they might have been seventh or eighth place. So that is why they are mentioning private number 7 or number 8 solution. Yeah, maybe we can start off with the solution, exact solution. So these are some of the augmentations they made use of. These are also based on the audio files and not the spectrograms augmentations.
so.
Then they also
It's
used,
interesting, right? You're also applying augmentations to the audio file and then later to the spectrogram as well. So that's quite unique. That's like it's obvious when you're reading it, but I just realized that.
yeah. Secondly, they use cut mix as well as mix up. These are quite popular augmentations in which are almost being used in almost every computer vision competition. So maybe you can look through it. And coming on to the loss functions, they took a mean of BC with logits loss as well as BC focal two-way loss. Yeah, that is kind of unique. Like they made use of focal loss as well as BC loss, maybe to kind of deal with the imbalanced dataset problem, because focal loss, as we all know, works better for imbalanced datasets. And alongside, they also made use of BC to somehow not like focal loss doesn't work so well when we have like for certain cases. So for that, they might have to simply average of both the losses, and this is also known as auxiliary loss in our terms. So that is what it consists. Maybe you can switch back to the time.
So they've shared the inference kernel, which is linked again in this,
Yeah, then they might have mentioned about the number two solution.
which I think we can skip. That just covers the controversial part that had happened, right?
Yeah, I think they simply did an ensemble of BirdNet with their solution, or I don't know, just use the BirdNet weights to predict.
Right. Uh, it's funny in retrospect, but at the time it was like not a good thing to cover. I would still like to skip it, but you all are welcome to read through it.
Anyway, I think we can move ahead. There's nothing much to add in this. This
So
solution seems quite similar to the number one place, except for that SCED model part. So yeah, I think
yeah,
most of the solutions would be similar in these competitions, because yeah, in audio classification there isn't much scope of novelty, I would say. Like so far, like mm, all the solutions are kind of similar. Maybe the tweaks could be in the post processing part, or maybe using different losses, or doing some sort of upsampling for the classes which have less number of samples. So I think these are the main three tasks in all these BirdClef competitions. First, you need to deal with the imbalanced data set. So either you can deal with that with upsampling, or applying some augmentations, or maybe a better loss function. Then I would say, like, secondly, you have train images of varying length. So you might want to apply some post processing to somehow generate better predictions for those 5 second spans. So that is also a thing. Like these are three, four things. If most of the solutions are quite common, way which differentiate the ranks is how you apply it and where you apply it. So that is a thing. Most of these things are mainly based on experimentation as well, I would say.
I was trying to do this in the background. So I asked I asked GPT-4 what are the recent developments, and it gave me a overview, which I interrupted. And then I asked it if you can like talk at a level of a researcher, because I think Agglers are at that level. And it's basically again re-summarizing what Nischay just mentioned. So
You
there are like
remember, right? It was trained on 2 years old data set,
yes,
ChatGPT. So
but
even
I
those,
don't know. Maybe they've also like there are clear instances, right, where they fine tuned on later data set as well. I'm not sure, but that's my hunch there. I mean, they
I'm
clearly like update it from time to time. So I don't know like if that makes it to the model or not. Okay, but we also will keep seeing, since I'm paying for the subscription, I will try to make the most use of it in the live streams without interrupting too much. But you can see the cool ones. The first three are the ones that Nishya also mentioned to some extent. I don't think he mentioned the third one, but I think I saw this in some discussion in one of the competitions.
Yeah, maybe you can work on that as well. Like noise reduction is a big deal in this signal processing data set. So there is always some scope of doing a better pre-processing, I would say, like using different filters or normalization techniques to generate better spectrograms or make use of better raw signals with less noise. So there is always one term known as signal to noise ratio. So there is always a ultimate aim for the signal processing guys to have better SNR score, to have lesser noise in that particular audio file or sample. So that is a thing. Maybe you can try out different normalization or pre-processing techniques as well. I forgot to mention it earlier.
Makes sense. Okay, so try to cover the third place solution. And Mr. already like pointed this out, but we'll see that they can end up repeating over and over, because that's the key for this. So the cool thing here is they've like also pointed out the external data sets that they had used. I'm not going to look them up. I assume like there's some well-known or maybe rare ones that fit into this competition quite well. So they had mixed the samples with background noise to improve robustness of the models. That makes sense. The rabbit hole continues here. So they had also used the SED model. I think this is the first of three teams to mention that they had used pseudo labels. And they had also hand labeled for small classes in SED model training. This in some competitions is not allowed. I think it was obviously allowed in this one, but this is cool to see. Um,
I think hand labeling is always allowed if it's done on training data set.
right, so it's not allowed on testing, right? If you have like access to the test images. Okay. Yeah, I always end up confusing. um, I think data sets are restrictive for access. That's where like most most of the angry discussion happens. Um, cool. So they had used the CNN proposed in second place of 2021. So let's take a look at that. And where is the CNN? This solution is an ensemble of several CNNs which take a Mel spectrogram representation. They use mix-up and add background noise augmentation. For instance, they predict on 5-second snippets. So it looks like Nischay kernel's ideas originated from here. Okay, so that's they had taken inspiration from there. Divide the scored birds into two sets and use different loss functions to train models for each one and augmentation. Let's take a look at these individually. I think the bird one is okay. We can take a look at the CNN model training. They did not use temporal mix up, which was mentioned in the solution above. Since the CNN model was used only for inference, it allowed them to use build reliable validation and monitor metrics for group 1 birds. For those models, they used BCE loss to select best models. However, with mix-up, models converged on the last epoch. This allowed them to include some models which were trained on full data in the final ensemble. So assume for some models they are trained on splits, and towards the end they ended up training some of them on the entire data set. This is a well-known trick on in most competition that most Kagglers end up using. So they share some details about the training setup. Nothing that stands out compared to the other solutions we already taken look at. These are hyperparameters, I think, specific to audio libraries. These might look new, but if you're working on these competition, you'd see them being repeated. For them, they say mix up is the most impactful one. Adding background noise is quite impactful. Spec augment and cut mix, they said help, but just a little. For things that didn't work, augment only scored birds did not work for them. Multiply loss for scored birds by 10. Weighted BC with weights proportionately to number of class appearances. So I think they were like trying to use some fancy way of balancing out the imbalanced classes in this one. Using pitch shift and random power did not work, and rating data didn't introduce much of a difference. So there's the answer to my theory. It was incorrect. Rating data was not helpful. Yeah, that's why we read these people, because I'm usually wrong and we always end up learning. Next, they share some more details about the SED model. I think these are quite standard, so I'm skipping past them. They share how they set the thresholding, and they say the default threshold for 21 birds was decided by watching the leaderboard. In the end, they use 0.05 for one group, but 0.04 gives a certain score above, gives more than 0.82 in private LB. And I don't know how or what the logic behind this is, but they say manually they set the threshold for this since our models trained with BCE laws predicted it reliably. And then they share the different models performance on both private and public. I think that's all I wanted to highlight in this. Anything else you found interesting, Nischay?
No, I think it's quite similar to other ones. So
Okay, let's
yeah,
try to
I
cover.
liked his idea about the grouping part, grouping certain birds, and then based on them, he did some sort of thresholding. So
Mhm. Okay, so this was a write up by Slime, and Slime is usually really active across different competitions. So when you see them in one, usually they will be on high rankings. Fourth place solution is easiest to cover, but they say they didn't have much time to participate. So the solution is overfitting last year's model, 2020 and 2021 model. Two differences: I train on all birds and then finish training on 21. Select a different LV threshold for each species, and here's a score. That's the fourth place solution. um here's the fifth one. I'll let you cover this if you want to.
okay, so they mainly use 9 models and certain backbones, including ECNFNet L0 and EfficientNet V2 series, ResNet 34, and Connext. Okay, so these are kind of popular models which are being used since 2021 competition, especially the ECNFNet L0 and EfficientNet V2S. Even my current solution uses EfficientNet V2S. You might probably have seen it in the earlier phase. So yeah. Then they did some sort of oversampling, I would say. Okay. Okay, so firstly, he picked up all the minority classes, those birds which have less than 20 samples, and then he manually oversampled all those birds. And then he mentioned that he cut them into some segments of 10 to 30 seconds. Okay, so he's basically trying to oversample the dataset. So for that, he manually cropped out certain
Mhm.
chopped off certain seconds of segments from different audios with for the birds which have less number of samples, and then he simply treated them as a new sample. So that's quite unique. Then for training, he mentioned the parameters he used to generate the Mel spectrograms. These are almost the same for everyone. So these parameters tweak can somehow help in generating a better spectrogram image with better dimensions. Like if you change the hope size, then it will change the height of your spectrogram. Similarly, the number of bins you use basically increase or decrease the time domain aspect. So these certain different parameters could also be tuned according to the image spectrogram which you want to generate. Then he used different type of augmentations which are quite similar to the earlier ones we saw.
Mhm.
And then he also used cutout and spectrogram augmentations as usual. Yeah, I think the solution is kind of completed. For post processing, maybe we can
I
have
think
a
these two data augmentation I hadn't seen them earlier. Maybe I overlooked them,
low
but
pass
I
is
just
nothing but, as I earlier mentioned about the low pass and band pass filter. So low pass basically just for, maybe he cropped out some of the frequencies audios which were having a certain spectrum below a certain frequency. So he simply removed those clip. So maybe that is a sort of augmentation he used. So
makes sense. And we can see that Philip is also happy that last year solutions are working quite well here. One thing I want to highlight, interestingly enough, this is quite common in top teams, right? Like some idea works for some teams in their pipeline, and another team the exact same idea doesn't perform at all. So that's always a common occurrence. I started earlier by saying we have set an ambitious goal of covering both year's top five solutions, and looks like we'll have to wait until next week. So I'll try to re-summarize what we have just learned by sharing the same in Hydrogen Torch. So I'll quickly re-summarize how you perform all of these pipelines, or how do you build these pipelines. So this again is a tool by top Kaggle grandmasters at H2O. Nischay, I think, will also probably be adding a few ideas here soon, is what I've been told. I don't know if I'm allowed to talk more about it, so I'll just leave it at that. What I'll do is I'll quickly import a dataset here, and let's find an audio one. We have ESC10. I don't see any other ones. So I'm just using the loaded datasets. Let's use the ESC10 one, and I'll probably ask Nischay to help me set up the hyperparameters here. So if you haven't seen this in the earlier live stream, this is a no code deep learning tool, and that's why I really enjoy showing it, because it can be somewhat interactive and it makes it really easy for us as a community to also like go through these uh, settings, and literally just through drop down menus you can really train state of the art models. So what I'll do is I'll now create an experiment based on this. I can take a look at the training data set, the different splits. I can play these audio files back. I can take a look at the stats. It's been loaded in correctly. I practiced this a while ago, so I know what I'm doing. That's why I'm running through it. Let's go to master settings, and Nischay will probably help me choose the hyperparameters here. So let's just train this on one fold. And I'll, do you want to tweak these, or do you want to leave them to auto?
I think they seem fine.
Yeah, you just took a scan in a second and you know, right?
Yeah, I mean, I'm quite huge that hope size is a multiple of, 2 to the power, and then sampling rate is quite common, 32K. Then
What is
training
Mel
cycle.
frequency bins?
Yeah, so basically for certain frequencies, you convert them into certain bins. So how many number of bins you want for each frequency is to kind of like cluster them in a bin. So for that, you use bin size.
Okay. Sorry, I was like in that teacher mode where you're like, oh, do you really know this? Can answer what we were just discussing. I thought he was like he was trolling me by saying he knows these settings. I was just making sure. Okay. Should we normalize the spectrogram with image normalization?
We can do that.
Okay. Mixup helped the one of the teams, right? So let's use Mixup, and you all can see that it's really easy to just include all of these techniques, right? here just by through the UI, and all of it's taken care. It's really well implemented, and if I may say so myself, these models run really fast. So you can get feedback in under a few minutes when you train them. I think we can kick off the model training. Anything else you wanted to change here?
I mean, we didn't see the label column, right? Or we did.
I looked at it. It was set up correctly, so I was speed running through it.
So is it multi-level or
I think it's single label this one.
okay? Then we can simply use BC loss.
PCE loss.
It's a metric. You can keep it anything.
This is what happens every time when I go to master settings. I have to search for it. But yes, the loss function is already set to BC. And let's keep this at ROC AUC, and I can kick off the experiment now. But I just wanted to re-summarize that, right? So you load in the spectrogram, you pre-process it with different techniques. Then you can also apply image processing or image augmentations there. So we applied mix up there, and then we can load in Resonate 50, for example, or a CNN model. So simply put, that's it for working with audio files. You can probably also do some thresholding like we saw in the other top solutions, but that was just a quick re-summary through Hydrogen Torch. So we started by setting the ambitious goal of going through all top 5 solutions. We obviously will not be able to do that. I'll mention Nischay's profile to everyone. So if you want to find Nischay, under the like button, you'll find his profiles, or you can find him on Kaggle, where he changes his profile picture every day. So you can, you can follow him there, and you can find his Twitter there as well. Uh, we I hope we you find the final solo gold in one of the competitions where you're competing, so that I can stop trolling you. But thanks again for joining, and we'll keep meeting everyone next weekend as well. I'll probably go to the learning quality competition, and next Saturday we'll go through the C Chat GPT implementation. So if you haven't seen the video, there's a video on the channel where Nischay and I had collaborated on Visual Chat GPT and created a nicer UI version of it. So you can also take a look at that, and we'll be walking you all through the code next Saturday. Uh, yeah, I think we can wrap up here. Thanks again for joining, Nischay, and for the help with helping us understand the top solutions this time. And I'm looking forward to reading your top solution in the next live stream, in one of the next live streams.
Thanks a lot for having me, and thanks for all those trolls about Solar Gold.
Yeah, they'll keep going. Uh, I think Willie just joined. Willie, we're wrapping up here. You can watch the recap. We were able to go through the top 5 solutions of 22. I might do a 21 live stream if there's enough requests, but we'll probably wrap up here. So thanks again, Nisha, and thanks everyone for watching.
Bye, guys.